So, how exactly do you find a tiny needle in a massive haystack when that haystack is buried 4 kilometers beneath the crushing weight of the North Atlantic? We are talking about a shattered shipwreck sitting 12,500 feet below the surface. To the average person, this sounds like a noble quest for history, a search for lost memories. But here is the major problem. At those depths, the ocean is not just cold and dark, it is lethal. The pressure at the bottom is nearly 400 times greater than at the surface. We are looking at roughly 6,000 pounds per square inch. To put that into perspective, imagine the weight of a massive school bus pressing down on an area the size of a single postage stamp. Here is where Hollywood imagination fails. You aren't sending human divers down there. Their bodies would be completely pulverized before they even reached the halfway mark. You aren't even sending standard military submarines. Most are simply too vulnerable to the extreme physics of the abyss. At that depth, a hull breach wouldn't just be a leak. The vessel would be flattened like a soda can in a hydraulic press within milliseconds. Simple, but brutal. So, how did a small team of researchers manage to locate the world's most famous wreck after decades of failure and do it in just 8 days? The answer is simple, but it is also a lie. The mission to find the Titanic wasn't just a scientific expedition. It was a high-stakes, top-secret naval operation. It was a calculated cover story for a wolf pack of advanced robotic technology designed for a completely different kind of hunt. The Navy wasn't just looking for rusted steel. They were searching for lost nuclear secrets in a high-pressure race against the Soviet Union. This wasn't a search, it was a tactical mission. But how do you establish a front line in total darkness? The answer lies in the robotic hunters that changed everything. To establish a front line in total darkness, the Navy relies on a strategy of layered surveillance and robotic endurance. The search for the Titanic wasn't a desperate gamble. It was a strictly calculated operation divided into distinct phases, each utilizing a masterpiece of technology designed to dominate the abyss. This brings us to Phase 1, the Scout in the Shadows. Meet the Argo. She isn't a submarine in the traditional sense. Argo is a 16-foot-long, unmanned deep-sea sled, a robotic platform that operates without a pilot or a cockpit. While the research vessel Knorr sits on the surface, Argo is towed 12,000 feet below on a high-strength umbilical cable. But here is the thing. Argo isn't just a camera on a rope. She is a masterpiece of underwater reconnaissance. Equipped with side-scan sonar and high-sensitivity television cameras, she acts as electronic eyes in the absolute blackness of the midnight zone. Her job is to create an invisible dome of detection over the seafloor. As Argo is towed across the bottom, her sonar pulses out, tracing the contours of the ocean floor like a long, patient finger. She doesn't see color or light. She sees echoes. Every rock, every trench, and every piece of debris is mapped in real time. This is the Wolfpack philosophy in action. Argo doesn't work alone. She is part of a synchronized network, relaying every frame of video back to the surface. But the ocean is massive, and the Titanic is a tiny speck. So, how do you ensure you don't miss a single scrap of steel? The answer lies in mapping the battlefield. The Navy didn't just guess where to look. They divided the search area into a precision-engineered grid, similar to a military patrol box. They established the northern sector, the central deep channel, and the south reserve. It was a grid search pattern so dense that nothing larger than a suitcase could remain hidden. For weeks, the crew of the Knorr watched the video monitors, seeing nothing but snow and endless miles of gray silt. But even with the best sensors, you eventually need eyes on the target. This brings us to Phase 2, the Silent Hunter. When the robotic sensors identify a potential target, the Navy launches the Alvin. Argo is the eyes, Alvin is the muscle. She is a deep ocean research submersible, a 23-foot-long titanium-hulled vessel designed for one thing: survival in the danger zone. While most submarines would be crushed flat at 4,000 meters, Alvin is built to shrug off the weight of the entire Atlantic. Her hull is a sphere of solid titanium, 6 inches thick. Inside, the environment is strictly controlled, but outside, the pressure is lethal. She is a silent hunter. Alvin carries a crew of 3 into an environment that is more hostile than the vacuum of space. She isn't just there to look. She is a robotic mothership in her own right. Equipped with hydraulic arms and high-intensity strobe lights, she can manipulate objects with the precision of a human hand while hovering in a current that would sweep a lesser vessel away. The coordination between Argo on the surface and Alvin in the deep creates a layered net of surveillance. Nothing flies, nothing sails, and nothing sits on the seafloor without being identified within seconds. But even with this ultimate weapon, the mission was a race against the clock. The Navy had only given the team a limited window of time. If they didn't find the wreck before the Knorr had to return to port, the mission would be a failure. Every hour, the pressure mounted. The team was working 24-hour shifts, staring at black and white monitors, waiting for a ghost to appear. The logic of the search was sound, the technology was superior, and the personnel were the best in the world. They had established their picket line. They had deployed their quiet hunters. Their collective radar and sonar coverage created an invisible dome over the graveyard of the Atlantic. But here is where Hollywood imagination fails. A mission like this isn't won with a sudden, dramatic discovery. It is won through grueling, patient logistics. It is the result of thousands of hours of looking at nothing until the nothing finally blinks. So, how do you handle the nightmare scenario? What happens when the sensors go dark or the umbilical cable snaps, leaving your multi-million-dollar robot lost in the abyss? The danger isn't over. The deeper you go, the more complex the operation becomes. As the days bled into weeks, the tension on the Nor reached a breaking point. They had mapped the north. They had cleared the central channel. They were down to their final reserve. The process is strictly calculated. Detect, localize, classify, identify. The team had detected anomalies. They had localized the search area, but they had yet to classify the find. They were looking for a needle, but they were also looking for a secret. The Navy's hidden agenda was always there, lurking beneath the waves like the Alvin itself. This wasn't just about a shipwreck. It was about proving that the United States could operate anywhere, at any depth, for any reason. The technology was a deterrent as much as it was a tool. But as the mission reached its final 72 hours, a major problem emerged. The weather was turning. Massive Atlantic swells began to rock the Knorr, making it nearly impossible to tow the Argo without snapping the cable. It was a high-risk naval operation that was about to turn into a catastrophe. The ocean was fighting back, and the simple, brutal reality of the deep was starting to win. They were out of time, out of luck, and nearly out of hope. But then, the cameras caught a flicker of something that didn't belong in nature. Something massive. Something made of steel. And that is when the true nature of the mission finally came to light. But here's the thing. The weather was turning, the clock was ticking, and the funding was about to vanish into the Atlantic mist. Most people believe this was a story about a scientist who just wanted to find a ship. But here is where Hollywood imagination fails. A mission of this scale requires more than just passion. It requires a massive, coordinated machine. And in 1985, that machine was the United States Navy. Ballard didn't just ask for a boat. He made a deal with the deep. At the time, the Navy had a much darker problem than a lost cruise liner. Two of their crown jewels, the nuclear-powered attack submarines USS Thresher and USS Scorpion, were sitting at the bottom of the Atlantic. These weren't just shipwrecks. They were massive, radioactive graveyards. The Navy needed to know two things. What happened to the reactors and had the Soviet Union reached them first? This wasn't a search for history. It was a high-stakes investigation into the most complex and lethal naval disasters of the Cold War. The Navy gave Ballard a simple but brutal ultimatum. He could use their ships and their technology to find the Titanic, but only if he found and mapped the nuclear subs first. This was the true nature of the mission. The search for the Titanic was the cover story, a brilliant strategic lie designed to keep the Soviet surveillance ships from realizing that the US was inspecting its lost nuclear secrets. So, how do you find a submarine that has been pulverized by the pressure of 4,000 meters? The answer lies in the debris. When the Thresher imploded, she didn't just sink. The pressure hull was torn to shreds in milliseconds. It was a devastating, explosive collapse that sent thousands of pieces of steel raining down onto the seafloor. As they mapped the Scorpion, Ballard noticed a pattern. The heavy parts stayed near the impact site, but the lighter debris was caught in the deep-sea currents, creating a long, patient trail that pointed directly back to the main wreck. It was a breadcrumb trail of destruction. This was the aha moment. Ballard realized that for 73 years, everyone had been looking for a massive, intact hull. They were looking for the needle, but they should have been looking for the trail. Or he had only 12 days left. 12 days to find a ship that had eluded the world for nearly a century. He decided to abandon the traditional grid search, and instead, he would sweep the ocean floor looking for the Titanic's debris field. He was betting everything on the logic of the deep, but the ocean is not a welcoming host. At these depths, the environment is strictly calculated to destroy anything that doesn't belong. The pressure is so intense that even a microscopic flaw in the Argo's camera housing would result in a catastrophic implosion. The cold is so absolute that electronics become brittle and fail without warning. The team was exhausted. They were staring at monitors showing endless, monotonous gray silt for 20 hours a day. Nothing but mud and rocks. Nothing flies, nothing sails, and nothing launches down here without a cost. On the night of September 1st, 1985, the tension on the Nor was at a breaking point. They were down to their final sector. If they didn't find something within the next 48 hours, they would have to turn back. The crew was silent. The only sound was the hum of the ship's engines and the rhythmic ping of the sonar. Argo was being towed through the darkness, her strobe lights flashing into the void like a desperate heartbeat. Then, at 12:48 a.m., a shape appeared. It wasn't a rock. It was a perfect man-made circle. As the camera panned over it, the team realized they weren't looking at a natural formation. It was a boiler, a massive riveted iron boiler, identical to the ones in the blueprints of the Olympic-class liners. The ghost had finally spoken. The excitement in the control room was absolute. It was a surge of pure adrenaline. But as they followed the trail, the scale of the tragedy began to sink in. They found pieces of coal. They found luggage. They found the shoes of people who had been dead for generations. And then, out of the blackness, the bow appeared. It was massive. It was lethal. It was a monument of rusted steel, standing 5 stories tall, emerging from the silt like a silent sentinel. After 73 years of silence, the Titanic had been located. But it wasn't a swift, clean victory. It was a moment of profound realization. The unsinkable ship had been snapped in half, her stern pulverized by the descent, her bow buried deep in the mud. The sheer power of the ocean had torn the world's largest moving object to shreds. It was a simple but brutal reminder of the hierarchy of the deep. Man builds, but the ocean consumes. The mission was a success. The Navy had their data on the nuclear subs, and the world had its answer to the Titanic. But as the strobe lights of the Argo reflected off the rusted brass of the ship's railings, the atmosphere changed. This wasn't just a tactical mission anymore. It was a gravesite. The high-stakes game of Cold War technology had led them to a place of absolute stillness. The logic of the search had been perfect. The technology of the Alvin and the Argo had been superior. But standing in the presence of that much history, the technology felt small. The Titanic sat there, invisible to the world for decades, while a wolf pack of robotic hunters finally breached her sanctuary. The invisible dome of the Atlantic had been pierced. But as the team watched the live feed, they realized that while they had found the ship, they hadn't conquered the ocean. They were just visitors in a danger zone that allowed them to stay only for a moment. The mission was over, but the story was just beginning. How do we take what we've learned and preserve it? How do we ensure that the next generation of hunters understands the cost of the search? This discovery changed everything we knew about deep-sea logistics and underwater reconnaissance. It proved that with the right combination of robotic endurance and calculated strategy, nothing is truly lost. But as the Nor prepared to head home, the crew looked back at the monitors one last time. The bow of the Titanic was fading back into the blackness, returning to the silence of the midnight zone. The hunt was over, the secret was out, and the ocean was already beginning to claim the wreck once again, one grain of silt at a time. Everything you just saw, the crushing currents, the silent hull, and the ghost of the North Atlantic, was recreated with a very specific purpose. In an era of automated content, we believe the details matter. This video wasn't just generated, it was built from the ground up. Every single frame was meticulously researched and animated by humans. We spent hundreds of hours cross-referencing technical deck plans, declassified mission logs, and engineering reports from the original 1985 expedition. Our goal is to ensure that when you see the Alvin or the Argo, you are seeing them exactly as they were in that lethal danger zone. You might have felt the heavy atmosphere in the visuals. That is intentional. We use a philosophy called material enforcing. We don't just want you to watch the descent. We want you to feel the massive weight of 6,000 pounds of pressure pressing against that titanium sphere. By focusing on the physical properties of corrugated steel, rusted iron rivets, and deep-sea silt, we bridge the gap between digital animation and the brutal reality of the deep. It's about making the invisible history visible again. There are still so many high-stakes operations and industrial marvels hidden in our history. We are a small team of 3 people dedicated to breaking down these complex stories with precision and heart. Every click and share helps us continue to produce these high-production breakdowns. If you value this kind of deep-dive research and handcrafted storytelling, please subscribe and join us. Don't miss a beat as we prepare for our next technical breakdown. Thank you for being part of this journey, and as always, stay curious.